So today we will start a new lesson. We talked about linear algebra, solving linear systems, how to deal with matrices, classical functions as how to make a mean over lines, over colors, how to make a measure, how to make a sum of lines, using what how to extract the submatrix, etc. Using all these tools, you can now calculate the vectorial product of two vectors. You can calculate the scalar product of two vectors. Maybe in quizzes or in homeworks or in something like this, I will give you exercises in this direction. All what you are doing in statics or in classical mechanics, you can do it now on math. So today, since we are working from the beginning on the command line, today we will switch on the scripts. We will try to run our first program. But before that, I want to introduce you the way to draw functions, to draw many functions separately or in the same plot, in the same figure. So that's why today we will discuss, I hope, because I want us to go a little bit rapidly. So we will talk about plots, how to draw a plot, etc. So how to draw your function on a command line, how to add the labeling on the x and y axis, the title, the different functions or different kind of figures, because when you draw a classical function, this is a point, but when you are drawing pi for statistical analysis or a histogram or a bar chart, this is another type of plot. Because in practice there are many types of plots in 2D, and there are many types of plots representing three-dimensional function. Imagine we have a function z, function of x and y. In this case, the name of function you will use would be different from the 2D ones. Okay? If you are drawing a trajectory of a point, it's also another type of function, etc., etc. The second point, how to generate a script and your own functions, how to create them. Because since the beginning we are working on the command line. But if you are working on the command line, it is a little bit difficult to share the results or to continue your job. If I have a big problem and I cut this problem into many sub-problems and I want to share this over all the students and give everyone a sub-problem to solve, and after this regroup all the scripts of all the sub-programs to create a bigger one, you can do this using the command line. So you will use scripts. Third point is the loops and the conditions. You need in practice to create loops for many times do a certain job. If condition, do job 1. If not, do action 2, etc., etc. While condition is satisfied, continue doing a job until this condition is not satisfied. And plotting a function in and calling it from a script. So let's take x going from minus 2 pi to 2 pi. This is a mathematical representation. We are okay that this is a mathematical representation of a function. I define a mathematical function x go from 2 pi to 2 pi, y equal cos x, z equals sine x. I'm giving the same notation as in math. And I would like to take a step h equal to 0, 1 to define x in MATLAB. So the first question, draw the different functions and different plots using the command line. I will define figure 1, I will draw the first function in the figure 1. After this, I will create the figure 2, and I will draw the second function of the figure 2. So in fine, I will get figure 1 with the function 1, figure 2 with the function 2, and figure 3 with the function 3. Okay? The x would be defined with the resolution of 0, 1. So, second point, I want to draw the different functions and the same plot. Sometimes you need to draw all your functions on the same plot. You want to make comparison, you want to calculate the intersection of two functions, the equilibrium point, for example, between two functions, or in engineering economy sometimes, the supply and demand of the market. The intersection of supply and demand is a point defining the equilibrium of the market. And the supply for market in the economic market, while the certain demand coming intersection in macroeconomy would be an equilibrium point. You can calculate it analytically if you are very good in mathematics. Sometimes it's difficult, but you can draw the functions and look graphically to the intersection point. And this is equilibrium. So there are many applications for this. And third point, doing this using script. So we try to do it using command line first. After this, we will basculate to scripts. So let's try. So in MATLAB, I will write that h. This is the command line. H equal to 0, 1. X going from minus 2 pi to 2 pi with a step h equals 0. Small remark. I just want to remind you that you have to define h before to use it. Y equal cosinus x, z equal sine x, t equal cosinus x dot product with sine x. Another remark, here, if you look at the help of MATLAB, MATLAB would tell you that the function cosine is defined and you can apply it directly to a vector or to a matrix. If you apply in mathematics, in MATLAB, if you write, for example, if you have a matrix 2, 1, 0, 1, 1, 1, 3, 0, 2, if you take this matrix as A, okay, if you write in MATLAB that B is equal to cosinus A, MATLAB will do what? Will take this A and the B would be cosinus 2, cosinus 1, cosinus 0, and cosinus 1, cosinus 1, cosinus 1, cosinus 3, cosinus 0, and cosinus 2. This is what means applying a cosine function or a sine function or a tangent or a logarithm or an exponential to all the built-in functions in MATLAB are defined. You can apply them like a block directly on matrices, which is a good thing. Now, when we will define our own functions, it will be difficult at the beginning to do it. But we can do it using loops. It is feasible. It's not so complicated to create functions that will be applied directly to matrices. And we will use loops in this case. Because we will run over the lines and the columns, and we would say that if you want to calculate the f of the matrix A, it would be f of every element of A. So we would run on lines and columns. So here, because your function is t equal to sine x var cos x, and you are calculating sine x for every element of x, and same thing for cosine, so you will make a dot product. Okay? So if you make a dot product for t, in this case, t1 would be cosinus of x1 var sine x1, t2 would be cosinus of x2 cross sine of x2, etc., etc. And we get the current vector representing this function. So let's try to do this. And if you calculate this, the second point would be how to draw. How to draw? First of all, we have to define the number. In general, plots are defined with numbers. Okay? They have which is a number. So if I write figure 1, It means you will create a figure called figure number 1. And this figure number 1, I will plot y in the y-axis, in the vertical axis, and x in horizontal axis. So it would be plot xy. Figure 2, plot xz. Figure 3, plot xt. Let's do it.
لازم نبدا دكتور فيجر 1 فيجر 2 ولا حيرة؟ لازم نبدا من فيجر 1.
Your friend is telling you, am I obliged to write here figure 1, figure 2, figure 3? No, I cannot start from figure 100. This one I will give it the number 2050. And this one I will give it the number figure 3. No problem. If you give a number to your figure, it means that this figure, every time you want to call this figure to draw or to add something on this figure, you have to call it its number. If you define figure 100, if you give the number 100 to this figure, and you plot x and y, and you want to add a labeling for x, for example, x-axis is the time, y-axis is velocity for a particle, because I love so much talking about transportation engineering, so all my examples would be around this. So if x would be a time and y is a velocity of a vehicle, if you want to add t in second or t in minutes and v in the labeling of your axis, you have to call again. After this, you will come here and write figure 100 and add me the axis. You will write the command for the x-axis and y-axis. Okay? Is it okay? Okay. Let's do it on MATLAB Direct. So, escape. So, we are working directly on the command line. H0.1, x equal to minus 2 pi, h 2 pi. I will take it as a current vector, okay? I will add the semicolons. I don't want to show this. I don't need. I want something of very clean. Y is equal to cosine x, okay? If you make rows, you will see that h is a number, x is 126 because you are going from minus 2 pi minus 6.28 to 6 with an increment step of 0.1. Okay, if you look to x, this is x. Okay, guys, this is x. You are incrementing every 0.1 point, and this is your y. This is your vector y, which is cosine of the first value, cosine of minus 2 pi. It means cosine 0, so it is equal to 1. Okay, 0 or minus 2 pi. It means the same thing. It means 0. So same thing. You are calculating the cosine until 2 pi, which is equal to 1. But he didn't reach 2 pi. The last value is not 2 pi. Yeah. If you calculate 2 pi minus y of and, look, I'm using now what we have seen before. The last value of y. There is a little difference. Okay. Sorry, minus x of and, there's a little difference. It's not equal, the last value of x is not equal to 2 pi because we increment and we didn't get 2 pi. We have seen this before. Now CLC, I will calculate also, so I calculated until now xy, z is equal to sine x, and t equal, I have two options here. First option, I can use directly sine x cos x. Or the smart way is to use y and z. Why? Because here you are recalculating sine x and you are recalculating cosine x. But here you have before calculating. So you don't need to recalculate again the same things. I can directly, you can do it like this, but better you can write that it is equal to y, z. Why? Because y is equal to cosinus x and z is equal to sine x. So we have to be, you have to keep this kind of things in mind. I have my three functions, CLC, whose, okay? I have x, y, and z. Your friend told us, am I obliged to start from figure 1? No, I'm not obliged. I can start from figure 100. Okay? I can start from figure 70. It's not a problem. Okay? So let's start from figure 100, for example. This is figure 100. Enter. If you run the function figure x with x number, MATLAB will create in reality an object figure. It's more complicated than a figure, but let's see it simply now. If you run figure, the function figure 1 or figure 2, MATLAB will create a space, a paper, given a number 100. Imagine you have a book with the numbered papers, and you have chosen the page number 100, and in this page 100 you will draw something, you will draw your figure. So let's reduce this. I will try to draw my, so plot xy. This is the default. By default, if you write plot xy, the color of your figure will be a continuous line with a blue color. This is the default. After this, you can manage your figures with different colors, with options, with symbols, etc. So if you run this with semicolon or without semicolon, you will get the same thing, because you are plotting. You are not calculating something. There's nothing returning to. So this is your first figure. Okay. This is so for minus 2 pi to 2 pi. MATLAB automatically adjusts the x and y limits. And here we start from minus 628 to 628. But MATLAB adjusts the limits to give you the best show. But you can adjust your axis limits. You have the options to do this. Okay, we will see all the options how to manipulate the limits of the axis, because we can zoom on the zone from minus 2 to 2 or from minus 2 to 0 only. Yeah, I can do this. Yeah. We defined figure. We gave a number to my figure. I gave a number to my figure. This is the figure 100. Okay? And I plot xy. It means I am representing y is a function of x. And x, I, y, and y were calculated before. We have calculated them. We have calculated them. Here we have calculated them. You have your x. Okay? This is your x, and this is your y. We have calculated this. So now I can define the figure 100 or 200. No problem. There is no problem in the numbering. It is better for you to start from 1, 2, 3 to be structured, to be organized. Okay? But you can choose any number you want. The most important thing is that you keep in mind, if you give a number to a figure, okay, this figure is defined by this number. Just, it is as simple as this. Figure 200 is another figure, so now you have 100. the figure number 200, okay? And I will plot x and z, okay? Now, I have xy, I have xz. If I superpose these two figures, I have the cosine and I have the sine. So, I can add a figure 300 and plot xt. So if you plot xt in this case, the periodicity would be the double. You have the frequency doubled, which is so figure 300 t, okay, this is t, this is y, and this is z. And you can add the grid. You can add the grid if you want to show the, if you want to, and to get access, etc. So this is how to do it directly using the command line. Now the second question here in the PowerPoint is to do it in the same plot using different colors. Okay? I will define a new plot. I will give it a number 4, figure 4 or 400, since we are doing the things in hundreds. I can write figure 4, there is no problem. Figure 4. In this figure 4, I will try to draw my functions one by one. I can do this one by one, or I can do this in one block. Okay, so if I come and I plot x and y in this figure 4, I will get this result. If you draw, we are now under the figure 4, okay? If I want to go back to figure 100, I write figure 100 and I redraw things on figure 100. You have to pick the good page and to draw on it. So you can't draw on the figure 100 without calling it, without picking the page. So if I want to draw now again on this figure, I have to write again figure 100 here. Okay? Now let me continue on the figure 4. I want to plot on the same figure, plot x and z. So we have before this, xy. If I want to add plot xz, the result would be like this. It means that MATLAB have erased the old figure. If you do in MATLAB something like this, if you do in MATLAB something like this, plot xy, and draw after this plot x. MATLAB would do in reality, he will erase all the figures, the old figures in the current plot, and overwrite it with another new. He will overwrite. You have to tell him, please don't overwrite. So this please is called hold on. Give me the figures, the old figures. So we will do it like this. This is a figure 4. I will write again, plot xy, enter. So this is my figure xy, okay? After this you will make hold on. So if you hold on, you can now add plot xz, okay? So the result would be this. If you add t, since this option is activated, you can add any function you want on the current figure. So if I write again plot xz, Okay, MATLAB would add me, sorry, plot xt, MATLAB would add me t on, but there's a problem. You know, we can't make the difference if it is the same color. Okay, so we have to give different colors to each figure. How to do this? In MATLAB, so I can make hold off. If I make hold off, it means that the next time I would draw a function, all these figures will be erased. So I will write plot xy, enter, and since the holding is off, you will overwrite every time you draw. This is by default in blue. If you want to draw another color, you will do it plot xz, and you know this bubble that appears every time you will use function built in MATLAB. This is the default, plot xy. This is another option, plot xy and line specification. This is a third option. If you want to do them by default in MATLAB, you can put plot xy, xz, xt, and MATLAB will do the job and will affect colors by default. Okay, and you can go. There are many other options in this function plot. So if I want to add a color, I have to add the option which is a string. Here you will add a string. So if I put R, it is for red. Since it is a string, it is between two axes, two counts. So this is plot xz. If it is in red, okay, look, but we are in mode hold off. So let's draw xy. xy, this is xy. Hold on, plot xz in red, and you have this result. Okay? You have, is it visible that this is blue and this is red? It's visible? You can add another color. The default colors are as follows. You have R for red, M for magenta, C for cyan, which is soft blue, default is blue, G for green, K for black. And if you Y for yellow, Y for yellow. After this, you can go inside the option of plot. You can personalize this. You can go inside the object. There are many ways to personalize that. You can put in there. You can create your own color. So if I put, for example, green, or maybe green, it's not a good, black, K for black, there is sorry, red for XZ and black for XT. The result would be this. Okay? So I know now that my Y function is in blue, the Z function is in red, and the G function with X is in black. But for someone who comes now, since there are some absence, they will ask us, where is the X, the Y function, what is the Z, and what is the T? So we have to give a legend. Okay? So if you want to give a legend to your functions, okay, you have to come here and write in the current figure, legend, CLC, legend, And I would add y as a function of y of x. It is a string. You can write anything. You can write good morning. No problem. Y of x, z of x. It is always a string. And t of x. Okay? So this is if you look, you have added by default here y of x, z of x, and t of x. Okay? Now you can go copy this figure, go in Word or in PowerPoint, and go at the end here, G. This is a node quiz, so no problem. You can go here, for example. Up. Let's and paste your figure and add a command for your presentation of statics or dynamics or fluid mechanics or what you want. You can manipulate your figures like this. Okay? So this is, we said we want to add in this figure the legend. We want to give a name for the x-axis and the name for the y-axis. For the x-axis, the command is xlabel. So I will add x-axis in meter, for example, if it is in meter, in second, if it is in second, etc. So if you run it, you will add automatically here x-axis in meter. What you are writing in the function x-axis would be written here. If you write anything bizarre, it will appear. No. It's a function. It's not. You didn't understand. I want this is the abscess, and this is the ordinate. Okay, but we have three functions to draw. I should call. Maybe I should call them F, G, and H. I can call this function F, G, and H. I didn't want to say that X is not. I mean that the X is the X-axis, and for the Y-axis I have three functions: Y, Z, and T. Maybe I should call them F, G, and H. Okay? So I added the x-axis. I can add also with the y label. And I call them ordinate. Ordinates in maybe in meter per second if these represent trajectories of three particles, for example. So if you write something, it would appear, okay? Here. You can add a title. Title. My first figure. Okay? So if you run this, you have this result in fine. You can copy, edit, copy figure, go to Word or to what you want. You can go here. I will delete this. And Control V to paste, or you can use the default. I'm using French version of Office, but it is the same interface. So you can add direct your figure here. Okay. Just legend. Why? You have made sometimes دائما أقول دائما في بعض الأحيان لما تعمل شيء خطأ ويعطيك نتيجة مقنعة وتمشي كده وتصير كده فرحان بس أنت في النهاية يعني اخترت يعني في النهاية حلش أو مخلوق غريب. Look what your friend did. He wrote something like this. Figure 5, for example. Look, plot x1, hold on. Okay? So by default, MATLAB will draw it in blue. After this, plot xz. So it would be in blue. Plot xt. It would be in blue. Now, he wrote plot xz in red, plot xt in which is better in black. Okay. Now if you do something like this, in reality we don't have, you didn't draw 3 fractions. You are drawing 1, 2, 3, 4. You can add 5 elements in the region. In fact, MATLAB draw plot x1 in blue, and when you wrote, he drew plot x in blue, this one in blue, and overwrote the first one. And he can draw just superpose the color yellow, or the red color, over the blue one. But if you add your legend, MATLAB will make the things by order. You draw this function first. MATLAB will affect the first element of your legend to this one, the second element to this one, the third element to this one, the fourth element. So you have to take care of this. Okay? If you draw a number of functions, if I drew, for example, z before y or t before y, in my legend, I have to invert. Otherwise, I get a problem. Okay? And you will know this by experience. It's not you can clear the figure and redraw. It will be okay, inshallah. So let's do it as a script. So we here I did it in red, magenta, and blue, red, and magenta. Okay. This is my script. Okay, you have this. You have this online now. Yesterday I put it online. This course and the next assignment. So to draw a script or to create a script, you would go to new script. Guys, أصدقائي. You will go to new script directly here, or new script function, etc. Even if a function is script, I do all the time new script, and I can give the heading for functions or what you want. So you have new class, new example, new figure, new chart, etc. All these are options of MATLAB. You can directly go ahead, do new script, or you can do edit, and a text editor will appear. You can do it like this. a new script. Okay, so MATLAB will open for you the text where you can write, and he will number your lines, line 1, line 2, line 3, like this. If you have an error in a certain line, MATLAB will tell you that you have an error in the line number 2 or 3 or 10, etc. And the command window is here. This is the default way how your script would appear. For me, for example, I prefer undocking the script from the interface. But we will talk about this. Second point, or you can do directly like this, edit, enter, and your text editor would appear. So you have two options. Okay, you have your text editor appearing here. Huh? You can come here. I like this. You don't need, you are not obliged. You can keep your script here, writing on it, and here you have your command line. Okay, no problem. You can, in AutoCAD, for example, you have always your command line here in AutoCAD. صح? Because these are scripting. These are script. You are doing script on AutoCAD. So same thing in SolidWorks or in other programming languages. For me, I prefer doing this. Go and undock. Okay. If you undock it, it would appear. You will get the same interface for MATLAB, and you. Sorry, because there are many figures. I will close. So if I want to close a figure, just a little, close, and you give the number of your figure. Figure 10, figure 1, figure 2. If you want to close like this all the figures, you do close all. So if you do close all, enter, all your figures would be closed. And you will lose them. Okay? If you want to keep them, you have to save the figure. And the format of saving is point fig. So you can open it another time. I prefer undocking and having the text in single interface and the command line in the other one. Okay? This is my way. You are not obliged to do it. You can keep your MATLAB like this. Go. Wait. You can go here at this small icon and go and dock the editor. So if you dock it, it would return in its initial position. So let's write our first script. Okay? I prefer when I start my script, this is a reflex for me. I start all the time by writing clear all. Because if I have any saved variable, I won't erase all variables to avoid any error. Sometime, if you keep the old variables present in memory, you can create problem for you. So erase all variables from memory, free your memory. Like this, you are okay. You don't have, you will not be in a position of. Maybe you are working with complex number, for example, and you defined an old program I as equal to 2. So you will get an error. So clear all your variable, close all your figures if you have figures, and do CLC to have a free board for the command window. Why? Because anytime you will get an error, you will get a message in red here. Okay, so, but you will correct it, صح? And you will run your script again. So, try when you start to run your script to clear your board, to be sure that if there is an error, it comes from only your script. Okay, so I start all the time, clear all, semicolon, close all, semicolon, CLC. I can do it like this, clear all, enter, close all, CLC. Here, MATLAB will not execute anything MATLAB will execute the things in the command line. This is a command line. This is a text. It is as you are writing on Word. You can even open a text editor and you write your script on the text editor. And you save it as a .m, as a MATLAB script, and you run it on MATLAB. Okay? By default, this is text. Okay? This is your, this is the command line, command window, CLC. Okay? Here, if you write a CLC, nothing changed because you are writing a text. It is an editor. متفقين شباب؟ It is an editor. هذا نص. أنت ستكتب النص، ستحرر النص اللي على أساسه بعدين when you run from this play, MATLAB will take all these commands and will execute them here on the command line one by one. Okay? This is the text. This is what MATLAB should do when you run your program. Okay? So I will save. I would save this, and I prefer, and I ask you to define a folder for you. For example, here I would define ME201 MA صح? MA script. I will write this, and please give logic name. Don't use space in your script. Don't use your names because it is a very bad idea, because you will find yourself at the end of the year Muhammad number 1, Muhammad number 2, Muhammad number 3, and you will not. So give a logic name. If it is for figuring or for plotting, don't give, for example, the name plot, because the name plot is the name of a function. Don't give a name. Don't give the name, for example, sign. If you give the name sign, MATLAB will use this instead of using the function sign. So create your own names. Let me show you. For example, my first or my script 1. My script 1. Okay? Enter. I created my script. I can run the script from many points. Look, we have all data in memory here. Sultan, we have all data here. Okay? Answer H, T, X, Y, etc. So when I run this program, MATLAB would clear all the variables, would close all the figures, and would make a CLC. And even if I have something here, I don't know, something of bizarre written, look. If I now come in here and run my script, look, if I run, okay. When you run your script, this interface would appear telling you that to run this file, you have two choices. You have first to change your directory and to go to the directory you created where the script is present, and to make the folder where the script exists your parent folder, or to add it to the path of MATLAB. Functions or scripts are not visible in MATLAB since we didn't add them in the path. يعني انت حتى تشتغل يعني MATLAB يعرف ان انت صنعت function, you create a function, and this function is called by your script, and this function it is in a certain directory. You have to give it the address. Okay? يعني انت لما تحتاج تثبت يعني لما تحتاج تعرف الادرس تبعه عشان تروح تجيبه نفس الشيء بالinstruction. You have to give the address. So this is what we call the path. You have to give MATLAB the path where is your function. Or if you run it. Look, for example, if I run this function, my script 1, here, from here. إذا أنا استعملت command line, my script 1. If I run it from the command line, MATLAB would not do anything. Why? Because he didn't know what is this function. Because he didn't have the address, he didn't have the path of this function or this script. So if you make enter, look, script, P. Okay? So if you do something like this, MATLAB, undefined function or variable my script one, because it's not defined. Okay? In any programming language, if you have a library or you have scripts or something, if you didn't add them to the path, the program would not see them. It is as simple as this, because it's a machine. You have to define things. So you have two things. I prefer this one. You go to your command line. Where is my command? Yeah. You go here at the in the home. Set path, okay? Set path, because you will set the path now. You will give the path where your script is. And MATLAB, every time you open MATLAB know where to find this function or this script. So set path, add folder or add folder with subfolders. If you have some time in a project, I can show you some of my projects. Sometimes in certain projects, for example, for me, I created a software with a PhD student working with me, software for traffic transportation. So I can define flow rates coming from nodes, from zones to zones, etc., to calculate the Registred Lesson. If the traffic light will be the green light will be this review and there, etc. In this kind of programs, these are very big programs. And you will define directly for geometry, to read the geometry, nodes, links, intersections, etc., etc. You have to define what kind of demand, length of traffic light, etc. This is how the traffic control elements, and you have to define your principal program and post-treatment scripts. So it is very big. I can show you this one example. It is a little bit big. So sometimes you need to, sometimes when you want to add something to the path, you have two choices. When you go to the set path, you have add folder. If it is only one folder, only a folder. If it is a folder containing subfolders, you will take this one. So if you add this folder, MATLAB would add you this folder with its subfolders. Okay. So I will go here, and now. So and just add this. Okay. Enter. So MATLAB will add you this in the path. So now if you run, save and close. Now if you run your script again, okay, MATLAB would make the job for you, which is clear all flows on CLC, because he knows where is the address. Thank you, guys. إن شاء الله يعني